section 11.1, we're going to talk about the basic concepts of probability and odds. So basically in this section, we're going to use previous knowledge from the previous two chapters, and you're going to probably feel like, I've seen this before, it's kind of easy, okay? So we're going to start with the spinner game. So I try to draw a picture of it. So I put a circle, and then we have 4 different colors. We have blue, brown, green, red. And it says the probability of landing on blue is 1/4 of the time. So what does that mean? When you have a spinner, normally it's divided into equal parts, and there's an equal chance of landing on each of the colors. In this case, there's 4 different colors, so the probability of landing on blue is 1 out of 4. So 1 out of 4, or sometimes you can write it as a decimal, so it will be 0.25. Okay? An activity such as spinning a spinner, tossing a coin, or rolling a die is called an experiment. Okay? The different results that can happen are called outcomes. The set of all possible outcomes is called a sample space. So we know the outcomes, we talked about that before. Sample space is basically all your outcomes, okay? So we're gonna write the sample space of this spinner. So in this case, I'm gonna write it right here. So in this case, you can have blue, you can land on blue, red, and it doesn't have to be in any specific order, brown or green. So this is your sample space, and the set is called S. Now, if we want to know the number of elements on S, we're going to say there's 4. Why? Because there's 4 possible outcomes, okay? An event is noted by E and is a subset of the sample space. Remember, a subset is smaller than the set or equal to. So a subset means only part of the set, okay? So in this case, we're going to say the event, E. In this case, I'm just going to write 2 colors, red and green. This is a subset of the sample space, okay? And in this case, the number of elements in the set E is only 2, okay? This is just an example. Alrighty, let's talk about theoretical probability. If an event E has a number of elements of E equally likely outcomes, and its sample space S has a number of elements in S equally likely outcomes, the theoretical probability of an event E is given by, so the probability of E is equal to the number of elements in E over the total number of possible outcomes. So basically, the number of elements in E on the event over the number of elements on the sample space, okay? So let's apply this into an example number 1. It says 3 fair coins are tossed. Find the probability of getting exactly 2 tails. Okay, so we've done this before. Let's write the number of possible outcomes first. Outcomes. Okay, so we have 3 coins, and each of the coins you either have heads or tails. So there's 2 possible outcomes for the first coin, 2 possible outcomes for the next one, and 2 possible outcomes for the last one. So that is the same as 2 to the third, which equals 8, okay? So this is the total number of possible outcomes. Okay, you have 8 different outcomes. So let's write out the sample space. So what are my 8 possible outcomes? So you can have heads, heads, heads. Remember, we've done this before. Heads, heads, tails. Heads, tails, heads. Tails, heads, heads. Make sure we don't miss any tails, tails, heads, tails, heads, tails, heads, tails, tails, and tails, tails, tails. Alright, 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 possible outcomes. Now what it's asking here is asking for the probability of exactly 2 tails. Exactly 2 tails. So if we look at our sample space, 2 tails will be this one, and this one. So that means my answer is going to be 3 out of the total possible outcomes, which is 8. So 3 out of 8 is my probability of getting exactly 2 tails. Okay. Now you've probably seen probability before. You've done probability. So this might be a little bit easy for most of you if this is not the first time. Okay, so let's look at more examples. Okay, so let's find the probability. Use the spinner below to answer the question. It says assume that it is equally probable that the pointer will land on any one of the 5 number spaces. If the pointer lands on the borderline, spin again. So borderline will be one of the divisions between the two numbers. Find the probability that the arrow will land on an odd number. So here we have numbers 1 through 5. Odd numbers, remember odd numbers is 1, 3, 5, dot, dot, dot. But this only goes to 5. So probability of an odd number. So the only odd ones are 1, 3, and 5. So that means is 3 out of the total possible outcomes. We have 5 numbers, so it's 3 out of 5. Ta-da! And that's it. I know, it sounds too easy to be true. I agree. Alright, let's talk about a single die. A single die is rolled twice. So the set of 36 equally likely outcomes are this ones. So I don't like the way this problem displays the possible outcomes. I kind of like them when they're in order, like we used to. But oh well, we'll deal with this. Find the probability of getting 2 numbers whose sum is greater than 10. Greater than 10 means more than 10. More than 10. Okay, so it will be 11 or 12. That's the max we can get here. So the sum of the 2 numbers has to be bigger than 10. So we go through here and we look for numbers that add up more than 10. 6 plus 6, that's 12. 6 plus 5, that's 11. This is 10, that's not good. 5 plus 6 is 11. And I think that's it. So the probability the sum is more than 10 is only going to be 3 out of the total possible outcomes, which is, they tell you right here, is 36. Now, when we leave the answer as a fraction, we always want to make sure it's in the simplest form. So you always want to make sure you can simplify if you can, which in this case, I can divide by 3 and by 3. And that's going to give me 1 over 12, and that's your final answer. Okay? All right, try the next one. The next one still talks about a die that is rolled twice, and it gives you all the possible outcomes, but now you're trying to find the probability of the 2 numbers whose sum is less than 13. Less than 13. So let's try to figure that out. Pause the video, give it a try, and then you can check your answer. Less than 13, so something smaller than 13. Well, the biggest sum you can get is 6 plus 6, which equals 12. So in this case, every single combination here, every single outcome is going to give you less than 13. So you have 36 out of 36, which equals 1 if you divide. There's a 100% chance, we call it, that you're going to get the sum of something less than 13. All right. Okay, that was kind of easy. Oh, yay, marbles. Okay, we have a bag with marbles of different colors. So we have 6 red, 3 blue, and 1 green. It says, what's the probability that you randomly select a marble that is not blue? Marble that is not blue. Okay, so probability of not blue. Something other than blue. Well, first of all, let's try to figure out the total. How many total marbles do you have? So we have 6 plus 3 plus 1. That looks like it's 10. So we have 10 marbles total. That will go in the denominator because that's the total possible marbles that we have, right? Now, how many of those are not blue? So it looks like red is not blue and green is not blue. So that will be 7 out of 10. Make sure you can't simplify. In this case, we cannot, so we just leave it like this. That was too easy. I know. Alright, let's get into something more interesting, I would say. And that is a deck of cards. You guys thought you were done with deck of cards. I know somebody from the class is going to be excited about this. Okay. It says find the probability of the following card hints from a 52 deck of cards. It says note the total number of ways just one, to be dealt a 5 card is, okay, so this is talking about, remember before we said if there's 52 cards and I'm choosing 5, what's the total number of ways that I can do that, right? So remember this number came over and over on the last chapter. This is the total number of ways. So I'm going to put that here. Total ways to pick 5 cards. Any 5 cards from the deck of cards, okay? Alright, we're going to use this because this is our total. This number is our total, so we're going to use it over and over, okay? So number 6, it says in poker, a flush, 5 in the same suit in any suit. Okay, so 5 that are the same suit. They could be hearts, diamonds, whatever you want, but they all have to be the same suit, okay? So, the same suit, you have 13 cards of the same suit, and you can choose in 5. Now, how many different suits do we have? We said we have 4. So I have to do this, 13 choose 5, and then times 4 because I have 4 different suits, okay? So I'm gonna make a note here. This is the number of suits. Diamonds, hearts, spades, blah, blah, blah. Okay, what is this equal to? Now remember, we're still finding the probability, so whatever this is equal to, I'm going to put it on the numerator, which in this case is 5,148, over the total number of ways of choosing 5 cards, which is this number. I don't want to be writing that number over and over, so I'm just going to write total ways, okay? And that's going to be equal to, in this case, I am going to divide this number by this, by the total, so I can get a decimal, okay? So in this case, it's going to be 0.00198, and these are my chances, or my probability of getting a flush in a poker game. Alright, let's try the next one. 4 of a kind. 4 cards of the same value. So it will be like, let me write this down. So 1, 2, 3, 4, 5. Remember, we're still choosing 5 cards, but 4 of them have to be the same value. So for example, what if I have ace, 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 and then the last one could be anything you want. So to get this part here, you're basically going to choose 4, choose 4, because there's 4 of the same value and you're choosing those 4. Now remember, when you're doing the combination where the number of where your n and your r is the same value, like in this case, that is always going to be equal to 1. Okay. Now, if you're taking 4 cards out of the total number of cards, which is 52, how many remaining cards you have? How many options you have for this last card? 52 minus 4, that will be 48. Now this is just for one card, right? Now remember, we have aces, we have 2, we have 3, we have 4, 5, 6, 7, 8, 9, 10, and then we have the jack, the queen, and the king, right? So we have to multiply this times 13, because we have 13 options to do this, okay? So 4 choose 4 times 48 times 13. Now this is equal to 1, so basically just 48 times 13. So what is this equal to? Oh, let me make a note here. 48. I'm gonna put choices left for the 5th card, okay? Because we took 4, so you have 48 cards left. Alrighty, so what is this equal to? Put in your calculator. Basically, it's 48 times 13, which is 624. Out of the total, remember the total is still this big number up here, okay? And we're gonna get a tiny little decimal that when you type it in your calculator, it's gonna say times 10 to the something negative. Now it's basically gonna be this 2.4 times 10 to the negative 4th. This is written in scientific notation, which means you can write it like this, I don't care. Which means you're gonna move the decimal 4 times to your left. So basically it's going to be 0.0002 There you go. They're equivalent. Okay? Let's see. But the calculator, when it's a tiny little decimal or a big number, uses scientific notation to be able to, so you can see it on the screen, okay? Because you only have a limited space on your screen. Alright, next. Full house. Now we want to know the probability of getting full house, which is 3 cards of one value and 2 cards of another value. So if we have 1, 2, 3, 4, 5 cards, for example, what if we get an ace, an ace, and an ace, and then a king and a king? That we actually have a really nice full house, right? So basically, here we're choosing, remember there's 4 aces, you're choosing 3. And then on this one, there's 4 kings, and you're choosing 2. So we're going to multiply that. But for this card, you have 13 options, because it's 13 different cards, right? Of the same value. And then, so for this card, you're going to have 13 options. So that's why we're going to multiply times 13. And then for the second card, you're not going to have 13 options anymore because you're using one of them already. You're going to be left with 12 options. So the second card is you're going to have 12 options, okay? So we're going to do 4 choose 3 times 4 choose 2 times 13 times 12. Alrighty, let's see what that's equal to. So 3,744, and we're still dividing by the total. And in this case, we get another small number, which is 1.44 times 10 to the negative 3. Or you can write it by moving the decimal 3 times to your left. So it's going to be 12144. There you go. Either or. Okay. Alrighty. Let's see. Looks like we're done with cards for this page. Okay. It says, if 3 boys and 2 girls are arranged at random in a row, what's the probability the 2 boys will not be in adjacent seats? So, adjacent means next to each other. So 2 boys are not gonna be sitting next to each other. Alrighty. Okay, let's find the total number of ways first. So we have 5 seats, and we have 5 options for the first seat. That's including the 3 boys and the 2 girls. And then if you sit one here, then you can't sit it here. So then you have 4, 3, 2, and 1, which is 5 factorial. 5 factorial is 120, I think. Double check. I'm pretty sure it's 520. 120, I mean. Okay, so now let's think about no boys in adjacent seats. Okay, so no 2 boys in adjacent seats. Okay, so no 2 boys are sitting next to each other, basically. So let's make a note here. No 2 boys in adjacent seats. Okay, 1, 2, 3, 4, 5. What does that mean? I'm gonna have to sit a boy, a girl, boy, girl, boy. No boys sitting next to each other. Okay. This is actually the only possible way to sit them, if we think about this. So let's make a note here. Only option. We have no option. A girl has to be sitting between the boys, and that's it. Alright, so how many boys we have as an option to sit on the first seat? The first seat has to be a boy. So we only have 3 boys. So 3 times how many options of girls we have here? There's only 2 girls. And then here, if you sit one boy here, you only have 2 options here. And you were sitting one girl here, there's only 1 option here. And for the last boy, you only have 1 option. Alrighty, what is that? So we have 3 times 2 times 2 times 1 times 1, which is basically 12. Alrighty. Okay, so the probability of no 2 boys adjacent is equal to 12, because that's the number of options that we have, over the total number of ways to sit the 5 kids. So over 120, which equals, we can actually simplify it if we divide by 12 and by 12. It's going to be 110. And that's the answer. Any questions? You guys are free to make a note of whatever questions you have, so when we meet in class, you guys can ask me those questions, okay? Alright, this is the last page I'm going to cover. It looks like it has a lot, but it will be quick and easy, I promise. So, empirical probability applies to situations in which we observe the frequency of occurrence of an event. The empirical probability of an event, E, is given by probability of E is equal to observed number of times E occurs over the total number of observed occurrences. Law of large numbers. As an experiment is repeated more and more times, the proportion of the outcomes favorable to a particular event will tend to come closer and closer to the theoretical probability of the event. Alright, let's look at some examples. We only have 2 on this page, and we'll see what this is talking about. Okay, solve and first express the answer as a fraction, then express the probability as a decimal round to the nearest 1,000, which is the 3rd decimal place, if necessary. Okay, so number 10. In 1999, the stock market took big swings up and down. The survey of 996 adult investors asked how often they tracked their portfolio. The table shows the investor's responses. What's the probability that an adult investor tracks his or her portfolio daily? Alright, so here it gives you the total number of adults that were basically took the survey. And here it tells you how often they check their portfolio. So daily, weekly, monthly, and it gives you a number of people who do that. So I'm going to put actually the total right here, 996. So we're looking for the number that checks daily. So the number that checks daily is this many, so 222 over the total number of adults that were taking the survey, 996. And we're going to divide this, and we're going to round to the first 3 decimals. Now if you do that, you should have 223, so 0.223, and that is our answer. That's it. Okay, so whenever we're working with problems where they give you a table and they give you specific numbers, we have to answer based on what is given, not on what we think or not on what we know or what can we predict. Okay, we're going to do the exact same thing on the next problem. So it says the distribution of 9,313 bachelor's degrees conferred by a local college is listed below by major. What's the probability that randomly selected degree is an engineer major? So here, this is what they're asking, right? We do know the total. The total is given. Where's my pen? Right here. The total is given, so it's 9,313. So we're looking at this number because those are the engineering. It's 868 out of the total number of degrees. We divide this and we round to the first 3 decimals. So it looks like it's 0.093. Alright, so we will finish the rest of the section live in class. So for now, thank you for watching this video.